Hello everyone, this is Davide from fpv.blue and I'm going to give you my reading of what's going on during this test flight. On the bottom right corner you have the frames per second, which is probably the most important number you can see on screen. Every time that falls below 56, some frames were dropped during video transmission because of a connection issue. And you can see this happening almost instantaneously after takeoff, which is something I didn't see before. It's difficult for me to believe I have interference in the 2.4 gigahertz band up here, so it must be coming from somewhere else, and I'm going to investigate. The goal of this flight is testing sensitivity. In the lab, sensitivity is well below minus 100 dBm, so that's the result I was trying to replicate today. We are now 40 meters away, and two antennas are getting a signal that is around minus 60 dBm. Signal to noise ratio is impeccable and the uplink is working, but I cannot make sense of what we are seeing here because we are seeing frames being dropped and there is no reason for that to happen. I'm probably gonna have to write some kind of logging system I can use in the field to make sense of this. So that's gonna take a day of work at least. 145 meters away, we're picking up some speed and then this happens. That was the receiver rebooting itself. It's something I literally never saw happening during development. That was code I wrote 2 years ago that saved the receiver from crashing and doesn't make sense, and it's not an issue per se, it's just proof of something funny going on. Anyway, signal is getting worse, and what we can see here during this freeze is the receiver giving up on the current channel parameters and deciding to trade video bandwidth for sensitivity to increase range. This is going to work, but only for a few seconds, as it does the same trade-off again, switching from 8 MHz to 4 MHz. And you can see that happening on the bottom left corner. Now, 4 MHz is meant as a fail-safe mode, as video bandwidth is capped at 2 megabits per second and quality goes down considerably. And it now decided to switch again to 2 MHz as the signal gets weaker. 2 MHz is capped at 1 megabit per second and quality is meant to be terrible, really. Sensitivity in this mode is better than minus 100 dBm in the lab, but that's not what we're seeing here, unfortunately, as the signal is at minus 90 dBm, which is of course at a 10 dB margin, and it's struggling to keep up. So we can now enjoy seeing the final moments of this prototype. We are almost 1.3 kilometers away, running 10 milliwatts, which is not perfect, but not terrible either. And right now the signal is great. Signal to noise ratio is above 5, 7 even. The system, given enough time, will switch back to the 8 MHz mode. So that's strange. Signal is supposed to get worse with distance, not better. So that's another question to answer. It might have been the antennas I saw near the ridge, but I personally doubt it. I think it was something else. What will happen in a few moments is the transmitter crashing, so that's a bug that didn't show up during development. It must have fear of fights or something, and I didn't write any recovery mechanism for it because it wasn't showing up. So the only thing I could do was shut down my radio, wait for RTL to kick in, and pray. And the drone never made it back, so that's how I lost my prototype. Now I'm building a second one that should be ready in a matter of days. Cheers!